In the last lecture, we talked about measurements, SI units, and prefixes. Today, we're going to learn another way chemists and scientists handle really large and really small numbers, and that way is called scientific notation. Scientific notation is like shorthand. So instead of writing out long strings of zeros, we rewrite numbers into two parts. And those two parts are, number one, a number between 1 and 10. And then the second part is a power of 10. And the rule of this is very simple. If you move a decimal point to the left, the exponent is positive. If you move the decimal point to the right, that would make the exponent negative. This way, a number such as 25,000 would become 2.5 times 10 to the fourth. And the way this happens is you kind of have to see that 25,000 as 25,000.00. You take that decimal point and then we move it over to the left. 1, 2, 3, 4 times, so that is between the 2 and the 5, and then you have that to the fourth and a value that is 2.5 times 10 to the fourth. Now, let's say you have a number such as 0.00082. That would end up being 8.2 times 10 to the negative fourth. How does this happen? Well, we have the decimal point over here, and we are moving it to the right. And so we will have a negative exponent. So we move it over 1, 2, 3, 4 places. And so you have 8.2 times 10 to the negative fourth. When you do this, it becomes easier to read and compare. And so it makes solving mathematical equations so much more easier. Now, we're going to go through a couple of problems. So the first one is we are going to take a large number and write it in scientific notation. So let's take the number 32,000. So you take 32,000 and imagine a decimal point right over here, right after the 32,000. So you're going to move that decimal point until you have a number between 1 and 10. And in this case, we can't do 32, so we're going to have to move it to between the 3 and the 2, so we can have a value that is 3.2. So we move it over 1, 2, 3, 4 places. And so we have 3.2 times 10 to the fourth. Now we're going to do another one. And this is going to be a small number in scientific notation. So we are going to try to write 0.00057 into scientific notation. So what you're going to do here is take the decimal point that's already present, and you're going to move it so that it is between a number that is between 1 and 10. So it only makes sense to do 5.7 here. So you're going to take this decimal point and you're going to go 1, 2, 3, 4 spots to the right, and right is negative. So then we have 5.7 times 10 to the negative fourth. And then one final practice problem that we could do together is we are going to take 4.2 times 10 to the negative third and try to put that in standard notation. So standard notation is going to be something with that really long decimal point with as many zeros as possible, or a very large value. So what you're going to do is you're going to take that -3 and then move it 3 decimal places to the left because it is a negative. So you're going to take 4.2 and go 1, 2, 3, and then put your decimal point. But we have 2 divids over here, so that's going to mean 2 zeros. So you're going to put 2 zeros before the 4. And so the answer to this would be 0.0042. So scientific notation is just another tool to make numbers easier so that you can read and work through it with ease. So remember the key ideas. Always make sure the first part is between 1 and 10. And when you're moving the decimal place to the left, you're going to have a positive exponent. If you're moving it to the right, you're going to have a negative exponent.